It is billions of years old, deeply hidden inside our planet, and yet it offers one of the most modern energy sources of the world to us: geothermal energy. Aside from the red-hot kernel of the Earth, numerous sun rays hit the blue planet every second, warming up the ground, the water and the air. Thus, the Earth is a huge source of energy, which is already being used with heat pumps for heating and producing warm water in some European countries. In Switzerland, 40% of all new buildings are being equipped with a heat pump. In Sweden, almost the entire population relies on geothermal energy. In 90% of all new houses, the occupants benefit from the efficiency and cleanliness of modern heat pumps. Constantly rising commodity prices, new laws, and a strong awareness of the consequences of the climate change lead to the public's focusing on regenerative energies. Selling heat pumps successfully requires intensive consulting talks. It is recommended to point out the following 3 good arguments in favor of geothermal heat. First, cost-effectiveness. With a low portion of electrical power amounting to about 25% and 75% free geothermal heat, a heat pump produces 100% naturally comfortable heat. Second, environmental friendliness. Heat pumps relieve the environment since they neither produce harmful CO2 nor do they require a chimney. Third, guaranteed future. Heat pumps render their owners independent of rising commodity prices and are convincing due to very low maintenance costs. In order to be able to benefit from the clear cost advantages of a heat pump, a source of geothermal heat has to be tapped. The most common heat sources are borehole heat exchanger. To be able to use it, a hole the depth of which is determined on the basis of the heat demand of the building and the geological conditions on site is drilled in the garden. A probe containing a special carrier fluid is introduced into the hole, taking up the geothermal heat and transporting it to the heat pump. Area collectors too use warmth from the soil via a broad collector field being installed slightly under the frost line. Well system, by means of which the approximately 10 degrees Celsius warm water is transported in the direction of the heat pump. It extracts some of the warmth and leads the water cooled down to approximately 6 degrees C back to the soil via an injection well. Ground drilling should be carried out by certified companies only. This ensures that the heat source is tapped in a professionally correct way. The procedure consists of 2 steps. First, drilling a hole and inserting the probe, and second, establishing the horizontal connection to the building. Depending on the planned depth, the drilling may take up to 1 workday. In the given example, there are 4 drillings with 50 meters of depth, each being carried out with a double U-probe. To stabilize the well, auxiliary piping is applied in the upper area. Then the drill pipes are removed and the geothermal heat probe containing the liquid is inserted. To allow the heat transfer from the soil to the probe to be as efficient as possible, spaces in the borehole are filled in with saponite. This is done via an additional pipe by means of which the mixture is pressed upward from the base of the probe. The second work step clears the way for transporting the generated geothermal heat into the house. This process is called the horizontal connection, since a ditch has to be dug beginning at the borehole under the frost line in order to connect the geothermal heat probe with the piping system of the building. The required wall breakthrough has to be carried out according to the applicable engineering rules. The heat pump is delivered on a transport-safe pallet that can easily be transported into the boiler room. In the given example, you can see a heat pump with a power output of 11 kilowatts designed for heating and producing warm water. Our Logotherm range of products realizes power outputs of up to 17 kilowatts at a maximum storage capacity of 450 litres. The scope of delivery includes rubber feet, a large breather, a sensor for outside and inside temperatures and heating reflux, as well as the filling and rinsing station, including a ball cock with contamination filter and pliers. In order to guarantee high operational safety, the system shown here is also equipped with a hot water tank and appropriate fittings in addition to a buffer storage. Before starting the installation, please carefully read the enclosed installation instructions and follow these instructions. First, tilt the heat pump slightly and screw on the rubber feet to the bottom side. They allow the device to be leveled. Please bear in mind that you have to maintain the specified minimum clearances to the surrounding devices and the walls. In the second step, important preparations must be made in the heating circuit and the feeder lines. Please install the expansion vessel and a safety module with pressure gauge in the heating circuit corresponding to the volume of the heating system. Now connect the pipes for the heat source side and link it to the geothermal heat probe at the brine distributor. The connections are sealed as usual and insulated against the fusion sealing cold. Now install the filling and rinsing station, the large breather, the safety module and the brine extension vessel. In order to complete the installation, an electrician installs the corresponding connections. For this purpose, the integrated electric consumers of the heat pump are connected according to the standards of the energy supply company. Before supplying power to the system, please check whether the phase sequence was set correctly. In addition, it is important to lay the sensor lines separated from the current carrying wiring. The reflux sensor has to be connected according to the manufacturer's installation instructions. Now it is time to start operation of the new heat pump. First of all, the hose pipes of the brine filling station are connected to the filling and rinsing station. It consists of 3 cut-off cocks and a bypass. Then the tank is filled. In the given example, ethylene glycol and water are mixed in order to reach the required antifreeze protection concentration for -15 degrees Celsius. Afterwards, bleed the circuit via the available bleeders. It is very important that the system is completely filled and there is no residual air left. Then check the pressure in the brine circuit and clean the contamination filter if necessary. When the pump is operational and all connections are tight, you can program the system for the heating and warm water operation. About 10 minutes after the commissioning, the final inspection of the heat pump is carried out. Now check, using the installation instructions, the spreads on the heating side and on the brine side. If required, optimize the values by adjusting the pump revolutions. If everything is all right and the system is running stable, you can explain the functions of the heat pump to the owners. Finally, the pipes have to be insulated against cold and heat loss on the heating side and on the brine side according to the regulations. The heat pump can now be operated. Buderus. Heat is our element.